Hi guys, today we're going to do areas of regular polygons. This is a very difficult lesson and make sure you're doing all the steps slowly and carefully, otherwise you will end up with some wrong answers and we don't want to do that, okay? So before you begin, you need to know some vocabulary. So here I have a hexagon and the hexagon has a center and the center is the point from which each of the vertices is equidistant, so you can circumscribe a circle around the hexagon. So that point is known as the center, and the distance from the center to the vertex is called the radius. However, there's something new for you here. The distance from the center to the side of the polygon is known as an apothem. So these are definitions you should know. Radius is the center to the vertex and apothem is the center to the side. And because this is a regular polygon, everything is the same. Each of the radii is obviously going to be the same. The apothem is going to be the same. The angles and the line segments, they are always going to be the same in a regular polygon. So this is from your textbook. You just need to know that you can circumscribe a circle about any regular polygon. The center of the regular polygon is the center of the circumscribed circle. And again, they tell you what is the radius and the apothem. And if you notice, the apothem is the height of the smaller triangle. So, and that is going to help us find the area of the full polygon. So the first thing you need to know is how to find the angle measures. So here, if I have, this is a pentagon, and in a pentagon, which is regular, if I draw all the radii, then I get 5 angles. And so in this case, if I divide 360 by 5, I get the full angle at the vertex of the triangle over here. So all of this is 360 divided by 5. But angle 2, which is part of the smaller triangle, is only half of angle 1. And then, of course, angle 3 is the complement of angle 2. So once you know angle 1, which is at the center, then you half it and you get angle 2. And then you may have to use special triangles. Oops, I see a spelling mistake. You can see special triangles or trigonometry to find the apothem, which is the height of the smaller triangle. So we're going to try a few. And again, this is difficult, so you want to pause the video every time and give it a try on your own. So here I have an octagon. So n is equal to 8. It's a 8-sided figure. It's 8. And what is the measure of each numbered angle? So if you want to find angle 1, you're going to take 360 and divide it by 8, which is 45. And so angle 2, which is part of the smaller triangle, is half of angle 1, which is going to be 22.5. And then angle 3 is the complement of angle 2, which is now going to be 67.5. And you're going to use all this information in a moment. So now let's see how we can find the area using the apothem. So if you know the side of the polygon, then you can find all 3 angles inside, and you're going to use either special triangles or trigonometry to find A, which is the vertical apothem. And so each of these triangles is going to be base times height divided by 2. So A times S divided by 2. And then you multiply it by the number of sides there are, and that would give you the sum of all the areas of the triangles. So the area using the apothem is A times S over 2, which is one triangle, times N, which is the number of sides. However, we know that perimeter is sides times the number of sides. So If I simplify this, it's ASN over 2, and S times N is perimeter. And this is the formula you're going to use most often, that the area of a regular polygon is half the product of the apothem and the perimeter. So let's try two sample problems here. On the left, we have a shape and we're told that one side is 8 and it's a regular polygon. And actually the apothem is given to you in this case. I want you to pause the video and try both of these questions. And now I am going to reveal. So the perimeter is n times s, so it's 10 times 8, which is 80. And area is half apothem times perimeter. So this is fairly straightforward. Make sure you answer with the proper units. Remember that area is always squared. In the next one, we have a regular pentagon. The apothem is 8 and each side is 11.6. So if n is equal to 5, then the perimeter is 11.6 times 5, which is 58. And that's the formula. You're going to plug in for A times P divided by 2, and the answer is 232 square centimeters. All right, so now it becomes a little bit more difficult. Here we have a hexagon. A honeycomb is a hexagon, and the length of only one side is given. So you have to use all the information to find the apothem and find any missing dimensions that you might need. Now here we already know each side is 3 millimeters. That means half of it is 1.5. So in the little triangle that we have inside, this is 1.5. And we know that 360 divided by 6 is going to give us 60. So the little angle here is 30. So basically, this is a 30-60 triangle. And you're going to use that information to find the apothem. So I have that the central angle is 60. And so we know that this is going to be a 30, 60, 90 triangle. And A is going to be 1.5 times radical 3. And once you know that, perimeter is S times N. So 3 times the number of sides, making it 18. And then the formula, you just plug it in and simplify carefully. Now, when you're doing this, I don't really want to see the decimal. If you can leave the answer in a radical, that's fine too. You just have to read the question on what it is asking. A whole number is okay. So let's try got it number 3. Again, I want you to pause the video, give it a try. And here is my solution. Since n is equal to 6, the central angle is 60. So you're going to make your little triangle, and remember that in the little triangle, this is going to be 30, because that's half of 60. This is side going to be 30, and the side is 8/16, so the bottom is going to be 8. And so let's give this a try. So again, we have a 30, 60, 90 triangle, and the apothem, which is on the right side over here, is going to be 8 radical 3. And then the perimeter is going to be 16 times 6, which is 96. And you plug it into the formula and you divide by 2. And again, a whole number is fine. The answer is 665 square feet. Now here's something new and different. The area of an equilateral triangle. So we just have a generic equilateral triangle. Each side is S, so the bottom half is S over 2. And you need to find the apothem here, or the height. And it's a 30-60 triangle, so the height is going to be S over 2 radical 3. We already know that the base, the entire base is S. So base times height divided by 2 is going to be S over 2 times S over 2 radical 3. And the numerator will all multiply out to give you s squared radical 3 over 4. Now, this is something you have to memorize so that you can use it very quickly. So add this to your list of formulas. And then I have 2 challenge questions. Everybody must try this to the best of their abilities. Pause the video, give it a try. This is the last thing on this video. All right, here is my answer. The span is the distance from one side to the other side of the polygon. What do you think the span is? Think about it for a moment. So, in case you haven't figured it out, the distance from the center to the side is this much, right? So, let me try this one better. Here we go. Oops. Okay. So that is the apothem. That means the span is equal to 2 times the apothem. So if you want to find the span, you have to find the apothem and multiply it by 2. So I've made a little triangle. And we know that the span is 30. That means the apothem is 15. And if the apothem is 15, then the side is 2x, which is 10 radical 3. And if the side is 10 radical 3, then the perimeter is 60 radical 3. And I can use all of that to find my area, which is 15 times 60 radical 3. 15 is your apothem, 60 radical 3 is your perimeter, and you divide that by 2. In the second one, we have a hexagon with sides of 6. And it's divided, and if you can see, this triangle inside is an equilateral triangle. So first you have to find the area of the full shape. And again, I have drawn, okay, I'm just going to explain this to you. I've drawn the triangle, one of the triangles, and the base is 6. Therefore, half the base is 3. So the apothem is 3 radical 3. And since each side is 6, the perimeter is 36. So your total area turns out to be 54 radical 3. However, the equilateral triangle in the middle, each of these sides is it's actually a span, right? And so that measurement is 2 times the apothem. And so I have an equilateral triangle where each side is 2 times the apothem. And I use the equilateral triangle formula. Be very careful, don't make mistakes. I hope I haven't made mistakes. And that is the answer. And let me know if you got these right. Goodbye, and I'll see you soon.